Before we begin with next bunch of questions, it would be helpful for us to review few properties of series and parallel connection. So let's revise from the start. So when charges flow, it is called as current. The cause of current is voltage, and to make use of it, you have resistance. In specifically, we looked into resistance of a wire. So we have R is equal to rho L by A for a fixed temperature and other physical condition. So this is the formula that we'll be using, where rho stands for resistivity, material dependent, length and area of cross section of the wire. So we can connect electrical components in series and parallel. So there's certain properties that we need to know that will surely help us in making the tougher question much easier. So we have a series and parallel connection. We'll be looking into each of it with the help of three perspectives. One is current, voltage, and third one is effective resistance. In terms of current, when it comes to series connection, the current remains same. So whatever current flows through one of the resistor, the same current will flow through other resistor. Doesn't matter what values they have. I have 1 ohm and 1000 ohm. Even though the difference is such a huge difference, same current will flow through. Okay. In parallel, it may or may not, the same current may or may not flow. So especially when you have, not especially, if you have by default different values in different lanes of the parallel connection, by default different current will flow. Okay. The amount of current flowing over here is much lesser than over here. So here it will be lesser. Here it will be a lot more. Right? Makes sense. And when you add this to, so if I call this as I1, we call this as I2, I1 plus I2 is your current flowing through this. And whatever current flows through this, the same current flows through this. When it comes to voltage, in series, they may or may not be the same. That is, voltage across, if I call this as ABC, VAB, it can be something like, if you calculate actually, we'll just take it as V1. And this will be very small. This will be a small value. And VBC will be a big value. Right? But they won't be the same when the resistors are different. One thing about VAB and VBC is they will add up to 10 volt. So VAB plus VBC by default will add up to 10 volt. That's about in series connection. The sum of the individual voltage across individual resistor will be equal to the voltage across the nodes from the start to the end. In parallel, the voltage will remain same. So the logic also, I have explained all of the logics, whatever I'm talking now. But yes, you need to remember all of this. Okay. So voltage in both of this will be 10 volt and 10 volt. When it comes to effective resistance, this is one thing that I'm not told, but it is something that you could have observed by now. In series, the effective resistance will be always greater than the highest resistance that is out there. It's quite simple. What is the effective resistance over here? 1 plus 1000, 1001. It's greater than both the resistors. So effective resistance over here, R AC is equal to 1 plus 1000, 1001 ohm. That's your effective resistance. So R here, RAB, 1 by RAB is equal to 1 by 1 plus 1 by 1000. So LCM is 1000, 1001 divided by 1000. Right? So RAB will be equal to 1000 divided by 1001, which will be equal to, I will use calculator, 1000 divided by 1001, 0.999, 0.999 ohm. So as you can see, it's lesser than the least value in the connection. Okay, so let me erase this so that you guys can see that. So this is 1000 and that is 1 ohm. So this effective resistance will be lesser than the least. always lesser than the given resistance, right? Whatever the resistance is given, parallel connection effective resistance will be always lesser than the given resistance. The lowest whatever the value is over that, it will be lesser than that. By default, the math tells that it's nothing to do with. It's we can see it, you know. So it's not a coincidence. That's what I mean. Even the math tells that, and the concept also tells that. If you think about it, majority if you have the current going in two ways, it's better than, say, this is a good road, but if you have one more road, by default there's some traffic that will go through that. Maybe cyclists go across there, or bikes or some small vehicles can go around, say, over there, and majority of the vehicles can go over here. If you think in terms of vehicles, so majority of the electrons will go through 1 ohm, while few electrons will go through 1000 ohm, but overall the current through the entire circuit will be more than, right, presence of only one resistor. It makes sense, right? Is it not? So this properties will help you guys doing numericals. It's must for you guys to, I've not written it in expanded way. I've explained it till now. You guys can expand it and write the details. But yes, this is must to know.